Hello everyone, I am Sharanya PS, Assistant Professor, Department of ISC, HA Institute of Engineering and Technology, Mangalore. In this video lecture, I will be dealing about multi-threading implementation, important two kinds of methods, isAlive and join, synchronization of thread and thread priorities. It is a continuation of the last session under multi-threaded programming. What is meant by multi-threading? How we can create these multiple threads. In the previous sessions, we have implemented the program which contains only two threads. One was main thread and one more child thread. By using this main thread, we can also create a multiple threads. How we can achieve that? We will see one example program which implements a multiple threads. Here, class thread implements runnable. As we discussed, threads can be implemented in two ways. One is by using the runnable interface and by using one more way is by extending the thread class. Here we are using the runnable interface. Inside this thread3 class, I have defined one name variable which is of a type string, and the thread3 constructor is called with the thread name as a parameter to that. And here under this thread3, I am defining a new variable, like I am giving this thread name to name variable what I have created now. And I have created a new object T which is of a thread kind and which takes two kinds of parameter. One is this is refers to the instance of the current class, that is thread3's instance is passed as a first argument and second argument is a name of the thread. These are the two parameters this thread method takes, which are defined under thread class, and then it prints new thread along with this. Whatever the returned information which is stored in T variable is also displayed. And we are starting the thread by using the method start. Along with the object T, we are calling the start method, which invokes internally run method. And inside the run, we have written try and catch block since we are using the sleep. Sleep method, if we are using in the thread, then we have to enclose within try and catch block. By using this for loop, we are printing the numbers from 5 to 1 in a decreasing order. And here with this statement, we are trying to bring the name along with the I value. Here it will begin with 5 and it will keep decrementing. And the name here is with respect to the name of the thread it executes. And it will be giving the delay of 1000 by using the method sleep. And it is defined by using the thread object. And inside the catch, we have just written one exceptional statement. If there is any exception occurs, this will get executed. And after that, we are printing name. Along with that, name here refers to the name of the thread plus exiting. This is a statement it will display after the completion of the thread execution. And here inside the main class, that is multi-threaded demo, here inside the main, I have called 3 threads. That is, I am calling the thread3 constructor by passing 1, 2 and 3 as a parameter values for thread name respectively. Here thread3 we have already defined under the previous class by the name thread3. Here the constructor thread3 contains the argument as thread name. For that it will take 1, 2 and 3 as a values. And in simple terms, here we are creating a new thread and these thread will have the name as 1, 2 and 3 respectively. And here thread name will be stored in the name variable and this name variable is referred in the rest of the code. That is, here when we are printing this comma name is getting printed and the new thread plus T. Here the name will be getting displayed. This is how we have created the thread, and then inside the try and the catch block we are once again using the sleep method just to display all the contents in a very systematic manner with the introduction of some 10,000 millisecond delay. And at the end your main thread will be getting executed and terminated. First thread that will begin its execution is the main, and the last thread that terminates is also the main thread. And here we will once all the execution is over, it will display it as main thread exiting. And if we see the output for this, we will run it in the Eclipse environment so that it will be cleared with the how the execution is differs with respect to multi-threading environment. As we discussed, multi-threading is the best way how we can run multiple jobs at a time. That is, if we are want to run a single method, that can be a part of that can be accessed by one threads, and those codes can be executed in a much faster manner than in the single threaded environment. If we look into the execution of the code that we have discussed now, here I will be executing this in the Eclipse environment. Here if we look into the output, that is, first as we observed in the code, there are total 3 threads we have created by the name 1, 2 and 3 respectively. And the first here new thread, that is thread, what it displays is it is the name of the thread, and the 5 refers to the priority of the thread. By default all the threads will have 5 as a priority. Main is the name of the group, that is a thread group. By default all thread will belongs to main group, and after that the thread second thread by the name 2 is getting executed. It starts its execution. That's why second thread that is getting run is 2, and next third, that is 3 is the name which we have given to differentiate among 3 different threads. Now inside the try block, that is with the for loop, we were trying to print one by one numbers starting from 5. Here initially 1, 2, 3 like this in a random manner, one by one thread will start its execution, and after it loops completion, one by one threads will terminate its processing, and finally the main thread exiting statement will be displayed. This is the one demonstration of how this multi-threaded environment will look by the execution of multiple threads in the under same class, or with the same code we can run different threads. And here the new thread is created by using this this is the name of the class what we are referring here, and we are passing the name of the thread 1, 2 and 3, and here we are just all the other statements that we have written is as a supporting codes which will work to demonstrate the working of multi-threaded environment. This is how the output of this current program will look like. New thread 1, 2 and 3, and after that one by one thread will keep executing. And this is the example for multi-threading. Next we'll look into the very important methods isAlive and join. These two methods are defined under the thread class, as the name indicates here, which is with respect to, which will give some features with respect to thread. Here isAlive is a method which will determine whether the thread is alive or not. The join, it will wait till the execution of the current thread, and it is not allowing any other thread to execute when the current thread is executing. And once the current thread is executed, after that we can process with the next thread. These are the main two methods which will get to know when other thread has ended. And here to determine thread has finished or not, we can either use isAlive or join. By using the isAlive method, we can determine the thread is alive. This will return a Boolean value, true or false. If the thread is still running, it will return true. If the thread has terminated, it will return the false value. And this join method will wait for the thread to finish, and after its completion, the next statement will get executed. And here all these methods are defined under the thread class. And if we look into the form of this isAlive method, final boolean is the return time, isAlive is the method it uses. And here, as I mentioned, it returns true if the thread upon which it is called is still running. Here we have to call this method along with the object of this thread, so that in particular to that thread from which we have called, it is going to give the status of that thread. And the same, if the thread is terminated or it has finished its execution, it will return false. And one more method here which is working is join, which will wait for the thread to finish its completion. And the way how we use here is final void join. And there's one more main point here is join. We have to write it within the try and catch block. In the catch block, we have to write the interrupted exception handling, and this try will retain this join method. Only sleep and the join need to be written in the try catch block. All the other methods that we have discussed under thread class can be directly accessed. And here it wait for the thread to die, and this methods wait until the thread on which it is called. That is, suppose if I have called this join method with respect to my first thread, it will wait till the termination of the first thread, and then after that it will continue with the next thread. And here if we look into the example for this, before looking into the textbook example, I have defined one simple code which will demonstrate the working of all these methods that we have discussed. This program can also be referred. This is much simpler than what is discussed, but it covers all the methods that we have discussed. Coming to the class here, as I mentioned, this thread can be implemented in two ways. One by using runnable interface, and one more by extending the thread. Here I have opted the second option, that is by extending the thread. In order to understand these concepts, please refer the previous session. Under that, I have completely discussed about how to create the thread. Class th is the name, and which extends thread. And inside the run method, I am creating the object for this thread, and it refers to the current thread which is executing. This current thread refers to the thread which is currently in the execution state. It will take the value from that, and it will be referred by using the object. And the main intention here is to make use of the different methods. First, we will see isAlive method, how it is going to work. Here, I will be printing first thread status plus t dot isAlive. One or the other thread will be executing. So, the thread which is currently executing, its status will be displayed. And inside the for loop, I am starting the loop variable from 0 to execute till 5, and I am giving some delay of 1000 millisecond, so that it will be displaying one by one values concurrently. And after that, I have not written anything inside the catch block, and I am trying to print the I value. And inside the main class, that is demo, inside the main I have created the two threads. That is, I'm referring these two threads by using the object T1 and T2 respectively, and the DH refers to the name what I have given here. And inside that, by using system.out.println, I'm trying to fetch the name of the thread. This can be done by using the method getName, which will return the name of the thread. That is, with respect to which thread I want to fetch the name. For that, I have to mention the object name of that thread, T1.getName, which will give the name of the T1 thread. And after that, by using the set name, I can set the new name for any thread. Here for T1, I'm setting the name of the thread as I am a thread. Here this get name will return the name. We'll see what is the name initially it returns, and after that how it is changed to I am thread. And with these two statements, first I am displaying the changed information, that is name of the thread after changing T1.getName. And with the one more important method here I am demonstrating is a getPriority. That concept I will be discussing in the theory later. This getPriority method will return the priority of the thread. By default, all the thread will have 5 as a default value. What this will return the integer value, what is the corresponding thread's priority. And here by using set priority, I can set any of the new priority value. Now in this case, I am passing the value as 8, so priority is set to 8. Now with respect to this, priority of the thread after changing is, with this statement I am trying to display that 8 onto the screen. And I'm starting this T1 dot start. The start method will start the execution of this T1 thread. And before moving to the try catch block, I will show without using the join method how the execution will be, and what is the use of this join method, how it is influencing on the output, we will look into later. There's before that, here with this T1, and I will just begin T1 and T2's execution. That is, in this code I have used first isAlive method, and these are the methods that I have used to fetch the details about the thread. Now when I execute this code, this is the output what it displays. First it will print the name of the thread keys. It displays as a 0 thread, that is the first thread that is getting executed. And then name of the thread, I am changing it as a I am a thread. That's why it is displayed by using the method getName. And here I have set the name by using setName method. And priority of the thread is displayed as 5 by default priority value, and after changing it displayed as 8. And here first we could see the status of the thread as a true. What does it mean? It is the current thread, that is T1 thread is currently running, and it printed as a true. And after that it started printing the second thread. During that time this statement got executed and it displayed as a true. And here first T1 is executed and T2 is executed, T1 and T2, like it is not in a very systematic manner, either T1 or T2, in depending on any execution, it will keep processing one by one thread. Now I will make a small change to the code with here I will write the join method. Now we'll see what is the purpose of this join. I need to write this join method inside the try catch block. I'm starting T2 thread here instead of starting here. I will start at the end. I have written the try block and catch block I have mentioned. And at the end, after completion of this try catch, I have written one system.out.println statement where it will display once again T1 whether it is alive or not. According to our explanation, this join method will wait till the termination of this T1, and after that we are trying to fetch the status of the T1 thread. Now we'll see how the output will look like, and after that I am starting the T2 thread. And if we execute this code after with a slight change here, the first thread it is getting executed here is same. The first parameter all statement will stay as it is, and here thread status is returned as a true because T1 is executing, and after that it printed 0 1 2 3 4 5. This is responsible with respect to thread 1, and here there's because the usage of the join, the thread 2 is not executed till the completion of the thread 1. After the completion of thread 1, thread 2 started its execution. This is the main purpose of using the join method. It will wait till the termination of the thread from which it is called, that is we have referred that as a T1 dot join, that is first thread. It has waiting till its termination, and with isAlive method we have fetched here what is the status of the first thread, and it returned as a false. That indicates T1 has terminated its execution, and after that this T2 thread has begun its execution. That's why the status has set to true, and 0 1 2 3 like that it will process through the loop. This is how we can demonstrate the major methods of this thread class, that is join, isAlive, and along with that I have implemented here get name and get priority, set priority, and set name. All these methods usage is demonstrated in this code. Now we'll proceed with the textbook code, what it is says about the join method. Here I have defined one. Please note the way the thread is created is by using the runnable interface. I have created the class thread4 and it implements runnable, and I have defined the name as one string which is responsible for holding the name of the thread. All this code will stay same as we discussed with the previous example, that is with respect to multiple threads example. All these main logic will be same. Apart from that, we are making use of this join and isAlive methods here. Thread4 constructor is defined with the thread name as a parameter, and we are assigning it to name, and we have created the object for this thread class, and which takes two parameters, instance of the current class and the name of the thread, which was referred by using the name variable. And we are printing new thread, and we are displaying with respect to this T, what is the name of the thread, and we are starting the thread, that is with respect to T dot start. And with the run method we are starting the execution of the thread that is running, and this acts as an entry point for the execution of the thread. And inside the try and block catch block we have referred the sleep method. I is starting from 5 and which keep decrementing till 1, and each time it is displaying the name, and along with that it is printing the value of I, and it gives the delay of 1000 in between milliseconds. And if there is any exception, this error statement will be displayed, and after that the execution of one thread it will print the system.out.println the name of the thread which is exiting. And inside the main class, that is demo join, here inside the main I have created the object 1, object 2 and object 3 for thread 4 constructor respectively. And the name of this thread are 1, 2 and 3 respectively. Here I have created the objects explicitly because I need to refer to all these threads by using these object names when I use the isAlive and join methods, so that I can specifically mention the thread to which I am referring. And I am printing first the status of the thread, that is object 1 dot p dot isAlive. This it checks whether this with respect to this object 1 thread, whether it is in a alive state or it has terminated. It will return true in all these three cases because currently all these three threads are in a running state. And here inside the try we have mentioned system.out.println. It is not allowing any other thread to execute. After this it will be calling object 1.p.join. It will wait till the termination of object 1 and then object 2, that is 2 thread will execute, and next 3, like that it will keep processing. And finally it is displaying the status once again. Thread 1 is alive, thread 2 is alive, and it displays the status of that with respect to isAlive method. If you look into the output here, how it looks, let me execute in the interface and show for the better understanding. When I execute this code, the same what I discussed here, first it is displaying here thread 2 is, first it displayed thread 1 with the basic informations as we referred in the previous program, and thread 1 is alive, it displays as true. Thread 2 is alive, displays as true, and thread 3 is alive and displays it as a true. These are all with respect to isAlive statement what we have written initially. And after that it is waiting for the thread to finish. By using the join method, it will wait for the first one thread to complete its execution. After that 2 will begin, after that 3, and this order will be keep repeating 1, 2, 3, and after that the same process will be continued. And after that here 2 exiting, 1 exiting and 3 exiting. Thread 1 is alive and all these will be displaying it as a false at the end. This is how it will wait till the termination of each of the thread, and after that it will continue its execution. If you look into the output here, 1, 2, 3, that is 5 it will be displaying, and 4, 3, 2, 1, that is one by one thread execution will occur. And it is not predictable that which thread is going to execute first. It is like, since all the threads will start executing at same time, it depends on the operating system which is giving the access for the CPU. It will execute first, and if we want to give some priority under that to which we have to execute first, we have to deal with the priority number for all these threads. After the execution of that, it will print false. And finally, the main thread, what it was given at the end statement, that will execute when all the threads execution has finished and main thread is also getting terminated. This is how we can make use of this join and isAlive method. Main summary of this isAlive and join method is, isAlive method is used to check whether the thread is in a active state or not. This will return either true or false. Here in this current state, the thread is currently running, that's why it printed as a true. At the end, when we check after the execution of everything, it printed as a false. Whereas in the join method, we need to call it along with the try catch block, and with respect to which thread it is called, it will wait till the termination of that thread and then it will continue its execution. So here It will wait for the first thread, next second thread, like that, and then it will process with. And next we'll see what is meant by this thread priority. As we are having some priorities in the some systems, same way even here in the threads is having some priority which will be held for the execution if that is like even with the processes, as we are having the priorities here which are used by the thread scheduler to decide when each thread should be allowed to run. Like if the thread is having the higher priority, which will be given more preference compared to the thread which is having the lower priority. If suppose if the if there is a currently lower priority thread is currently running, if there is any other thread with the higher priority appears, then the lower priority thread will be preempted and the access will be given to higher priority. This is like if it is getting stopped, then it may be going to sleep or in the waiting state or in the IO state. And here it will be most of the time lower priority thread will be getting preempted. And to get some details about this priority, as we implemented the program, we are using set priority method, which will set the priority by giving the value what is mentioned in the method, that is integer level. This level refers to three different values, that is one is minimum priority, maximum priority, and one more that we refer as a norm priority. This minimum priority refers to the lowest value, that is 1, and maximum priority that normally referred as 10, that is ranges from 1 to 10. And this norm priority refers to a default value, that is normally 5. Either we can mention these values or we can directly specify the numbers as I implemented in the code. Here with this set priority method, we can explicitly specify what is the priority of that particular thread. And since here we have to set the priority in specific to which thread we have to mention the priority, we have to explicitly mention with respect to object. And here with because all these methods are static final variable, all these we have to mention these by using the objects. And current priority we can fetch it by using the method get priority, which will return the integer value which represent the current priority value of that corresponding thread. And the next very important concept is synchronization. What is this synchronization and how it is important in the multi-threaded environment? As we observe here, in the multi-threaded environment, not only one thread is executing at a time. There will be a large number of threads which will be keep executing and accessing one or the other resources, which may access a same file. In that case, the file that it refers acts like a resource. In those situations, there should not be any controversy when it referred to the same file. One by one, all the threads need to access the shareable resource. All these will be taken care by this synchronization concept. That is, the process of like accessing the shared resources by the thread, that way how it is controlled, we refer it as a synchronization in simple terms. That is, when two or more threads needs access to a shared resource, they need some way to ensure that the resources will be used by only one thread at a time. That is, those resources cannot be accessible at a time by multiple threads. In order to overcome some problems when it accesses at the same time, there should be some locking mechanism need to be implemented, so that when first thread is accessing the resource, Next, upcoming threads which want the access to those resource need to be locked. After the completion of this resource access by the first thread, the access can be provided to the any other requesting thread. This concept almost which holds similar to the process synchronization. And here the main purpose of this synchronization will help in that data inconsistency problem. Data will be shared in a very systematic manner since at a time only one thread can access a resource. And here one more thing is the block of code known as like critical section problem, what we referred in operating system, can also be managed. That is a code which will be accessed by multiple threads that need to be secured. That the data that we refer in that should be modified in a very systematic manner. That code what we refer is not, which is shared by multiple threads, we normally refer as a critical section. Here also some locking mechanism need to be implemented as we followed in the process concept. That is here the concept what it follows here is a monitor, which is similar to semaphores that is implemented in the processes. That is this monitor acts like an object that is used as a mutually exclusive lock. In the sense, one thread can own a monitor at a given time. That is like if we define some code which is acting like a synchronized code, then at a time those code can be accessible by only one thread. If when a thread acquires a lock, it is said to have entered the monitor, and during that time if any other thread is trying to access that, which will be getting blocked, or those will be in a suspended state. When the first thread is getting exits from the monitor, then only the other threads can enter into the monitor. These like other threads are said to be will be in a waiting for the monitor. That is for the resources it will be waiting. Here the synchronization or this thread synchronization can be achieved in majorly two types. One, by using the keyword synchronized along with the method which need to be acts like a synchronized code. That is, we have to attach this synchronized keyword along with the method definition. And one more way is by implementing the synchronized method itself. We'll see both with the example. Before looking into the textbook code, I will be dealing with the simple code. Here I have created 3 different classes, one as A and one more as a B and one more as a synchronization test. That is, here the main agenda of this code is to demonstrate the synchronization. That is, at a time only one by one thread need to execute. That is what we could see as a final output. First we'll see without using the synchronization here. That is how the output will be deferred. We could make the difference in such case. This code what I have written, first I will give the details about this. First I have created a simple class A and I have defined one method called as add, and I am taking one variable n, that is parameter n, and I am creating the object for this thread class T, and I am referring to the current thread by using the method current thread. And I am running one loop for loop which will fetch the name of the thread, and it will compute this new value by adding the n value which I have defined in the function call, along with this I value will be added and it is getting printed. and in the class B which extends the thread. So here extend thread method is used to define the thread, and I'm creating the object of this class A, and with that I'm calling the method which I have defined here. Function definition is called by using A1, that is class A's method, and this class is a public, so I can access it. And add, and I am passing the value of this n as a 10. So when I call this 10 will go and referred with the value variable n. And in the main class, that is synchronous test, inside the main I am creating the object for class B, and with that I am defining the thread T1 and T2 here, and I'm referred with respect to the object of the class B, as we followed when we are creating the thread by using the extends method. And here I'm setting the name for this T1 thread as T1 thread, and for T2 thread as a T2 thread by using the method set name. And after that I'm calling start method for T1 and T2 respectively. This is a simple code which is used to see how this synchronization will work. Now I have not done any synchronization mechanism. We'll see how the output will look like. This is the output of this code. That is, first it is displaying the new thread, and this is the old output what it displays. When I execute this, the output it displays as first T1 thread is getting executed, and it displayed thread T1 thread. This is the name of the thread what it displayed here with the statement what I given in the println, and then which is the name of the thread which I have specified in the main set name method. And after that, here 11 is the value it printed by 10 as a argument that I have passed, plus 1 value which is getting added, and it is displaying. Now T1 thread is keep executing, and after that T2 is getting executed. Now if we add some synchronized keyword to the method, how it will differ to the output we'll look into. That is, I'm using synchronized keyword here, which will help to synchronize. We cannot predict the way how the thread is getting executed. By using the synchronized keyword here, we can strictly say which thread which is called first is need to first. That is normal usage why we are making synchronized. When we look into now here with respect to the output, with this small change, first T1 is getting executed, and after that T2 is getting executed. With the previous one, when I did not use synchronized, T2 was the first one, it is getting executed. Now instead of synchronized, one more way how can I implement the synchronized is by using the method synchronized along with the object to which it need to run to the thread, and I need to call the corresponding method to which this synchronized need to be applied. And please note, this synchronization can be applied to methods and cannot be applied to variables and classes. So when I execute this code once again with the synchronized method implementation, here in a very systematic manner, T1 first will execute, and after that T2 thread will execute. This is the simple usage of this synchronized implementation. That is, one by using synchronized keyword directly in the method, and one more by using the defining the synchronized method. Now we'll look into the one more code which is discussed in the textbook. This here we are defining the class called as call me, and inside that we have defined one method called as call, and we are passing one message as a string, and we are printing the message by opening this open bracket, and we are writing try and catch block since we are using the sleep. And inside the caller method, which is implementing the runnable interface with the message as a string variable, and call me's object is created. This is the call me class. Its object is created. Here constructor, this is a method what it is defined. Here inside this caller, the constructor is called with the two parameter, one as a tag and one more as a string. This tag will refer to the object, and yes refers to the string that we need to be displayed. And here this is getting a tag value is getting stored in target variable, and yes in message. And here we are creating the thread object, that either we can write this thread t equal to new thread, and passing this as a current object of the class, and previously we were passing along with this name of the thread as well. Here instead of that passing the name of the thread, here we are printing it by using the method. That is a major change. And after that we are starting the thread, and inside the run we are calling the method call what we have defined here. And this message is a statement, that is here it will be taking message as argument. So message what we are referring here will be passed to that as a argument. And inside the main class synchronous, here we are calling or creating three threads, that is which are referred by using object 1, object 2 and object 3 objects by caller. Caller is a parameterized constructor that I am referring, which takes two arguments, one as a target and this is the name of the thread here, which will be referred by using yes. And the target is the object that we have created along for this call me class, which I am referring here. And after that here call me is this class what I referred here. And here after the execution of all these three, it will be waiting for the thread to terminate, which can be accomplished by using the join method. Here join method is used. These are the code which does not use the synchronization, just we have used the join method, and it is printing the exception if there is any exception. By the execution of this code, the output what it displays is hello. After that it is printing the open bracket and synchronized and then open bracket, and what it is like a jumbled output that we could see. It is not in a very synchronized manner. That is, this was mentioned with respect to first thread, and this is second thread, and this was a third thread. After this execution of hello, synchronized and word, thread will terminate. And the problem that we observe here is we call it as a racing condition. That is, thread will be keep racing among themselves to finalize its execution. So the output what it displays will not be in a predictable manner. That is, unpredictable output what it is getting displayed, that we normally refer as a race condition. That is, for one resource all threads are trying to acquire for the one particular resource. Here to fix this particular problem what we have observed, one best way is by using the synchronization. That is, here we have, even though we have called this join method, but one major drawback here is we need to keep calling this join method with the each object of the thread. If there is 100 threads, then we have to call this join method along with the 100 threads object. It is not a good way of coding. instead of that, we can use a synchronized keyword. The synchronized keyword need to be defined before this call method. That is synchronized void call need to be appended along with this call method. This prevents the other threads from entering inside the call method while another thread is using it. That is, at a time, this call method is accessible by only one thread. This is what it acts like a key here now. Only one thread can be able to access it. Now, if we look into the execution after that, this is how the output will look like. Here the thread enters any synchronized method on an instance. No other thread can enter any other synchronized method on the same instance. With the instant, it will be referred to that, and at a time only one object will be referred, thread's object will be referred to access that method. Now, if we look into this, how this will be implemented, first we'll look into the code without using the synchronization. Here I have not defined the synchronized keyword, and here I have not defined the synchronized method as well. If I run this code, and now you could see the jumbled output which is not in the order. Now this problem I will solve by using synchronized keyword with the method which is accessed by multiple thread. And after defining the keyword synchronized with the method, I will execute the code, and you could see the output in a synchronized manner. That is, first it will display hello and synchronized, and then the word. This is how it will be differed from program hello. See, the output that we could see is hello synchronized word. This is how we can systematically synchronize the execution of the thread. One more way here is by using the synchronized method. That is, inside the run method, I need to make use of synchronized method, and I need to refer by using the object for which it need to execute. So target here I am referred with the name, and I am running by using the synchronized block now. With this also it will be allowed to execute in a systematic manner. Hello word synchronized. These are the two ways how we can establish the synchronization to the threads. And here we have to, this is the second method. We need to call to the method defined by this class inside the synchronized block. That is, here we need to call to which we need to apply this synchronization. That is, function call we have to make it from this particular section. So here call to method, that is member of the object, here what we are referring, occurs only after the current thread has successfully entered the object's monitor. After this object's monitor, then only it will allow to execute the next thread. After the changes here, this is where what I did the change in the implementation. That is synchronized. Target is object that I am referring. Target.call. I am calling the method call what I have defined. So this call method is called from synchronized method. This is how we can implement the synchronization. Either of these two we can opt depending on the requirement. One drawback of this synchronized keyword if we are using is, suppose if we are define the code, it is fine. Suppose if the code is under some interfaces, then those methods we are not having the access to change, or if the methods are defined by someone else, and in those cases we are not allowed to make the changes to the method. So this synchronized keyword cannot be used. And this will take a lot of time as well if we are using the synchronized keyword just with the method. That is, with that T1 synchronized keyword, T1 will execute for some time and T2 will execute like that. The time when it reaches to the last thread, it is taking a lot of time, and which can be overcome if we are working with the synchronized method. Your execution will be faster, and which can be applicable to any kind of the code that was built. This is all about today's lecture video, where I discussed in detail about thread synchronization, and then priorities, and isAlive, and one more join method, very important concepts what I discussed in today's class, and multi-threading implementation. All these topics are repeatedly asked. Please go through the programs which I discussed in the slides, as well as the programs which I implemented. Those can also be used, which is very simple codes what I have referred. And this covers your module 4 along with the sir's video. This completes the entire portion of the module 4 and object oriented concept subjects. We have covered all the topics, and this is the end of the session. Thank you for listening.